Another extremely useful mechanism or tool that is used for filtering prefixes is called Prefix-List. It's a little bit better than access control list because not only can it match on the number of bits, but it can also consider the number of bits in network mask. So as an example, I'm going to use that Prefix-List to filter prefixes being introduced into OSPF cloud from EIGRP. So R6 is my ASBR or Autonomous System Boundary Router. It runs both OSPF here and runs EIGRP between itself and Internet 3 router and introduces a number of external prefixes. Now let's just quickly have a look at the so show IP protocols and maybe include routing protocol. So it runs protocol. It runs both EIGRP Autonomous System 100 and OSPF, and OSPF learns the prefixes from EIGRP. Show IP, maybe let's jump here, show run section router OSPF. So let's jump and see what this command redistribute EIGRP 100 subnets. That means it introduces all the prefixes from EIGRP world Autonomous System 100 and includes the subnets. As a result of that, my R3, let's just pick R3 here, is going to learn show IP route OSPF include the external type 2, a number of prefixes from that EIGRP cloud. Let's just say, for argument's sake, I want to filter. I don't want to introduce all of these into OSPF, but I want to introduce maybe everything that is starting with 30. So we can use access control lists for that, but I'm going to be much more flexible later. So Prefix-List is a more interesting tool to use, or more versatile tool for me. So what I'm going to do is here, I'm going to say that conft, and if this was access control list, obviously I would be using IP access list or access list command. Here it's the command is IP prefix list. IP prefix list. What follows is a sequence number. So I can say, for example, 5 or 10. If I don't specify sequence number, it starts with 5 and it will increment each statement for the same prefix list by 5. So it's going to be 5, 10, 15, and so on. So I'm going to say a word. I'm going to call it EIGRP, let's say, because those are EIGRP prefixes. Now, what follows next is deny or permit. And just like access control list, it goes through the same process of top-down process. If there's a match, the remaining entries are ignored, and there is an implicit deny everything else at the end. Let's start with something simple. So what is different about prefix list is that when we specify, so let's just say for the argument's sake, I'm going to specify that I'm going to permit, of course, for a redistribution. I'm going to say what is the prefix that I want to introduce as a permit. Now, in my case, all these will be anything 30.33. So there's a common denominator here, 30.33. All of them have the same common number of bits. So I'm going to say 30 and 33 and 00. Now, here's the gotcha. So when I specify that, it prompts me also for the network mask. So this is a gotcha, because if I say, let's say, so check the first 16 bits, which is gonna be 30.33. Let's actually hit enter right now and see what it does. So what I'm going to use this, by the way, it's not going to work, because what that means here is that it is looking for the exact match, which is 30.33.0. Now 16 means that these are ignored, and what this means, without an extra operator, which I'm going to use in a moment, this means that it expects to see 30.33.0.0/16, exactly like it. since I don't have it, because all my prefixes are 30, 33 something, 0, 0/24, not 16, 1, and so on, so it's not going to work. So let's apply that and see that it doesn't actually work first. So what I'm going to do now, unfortunately, during the redistribution, there's no option to match on prefix list. There's an option to match on a route map, so a route map will be the next topic. But for now, let's just assume that we know how to use route map. Route map, I'll call it EIGRP _to OSPF, permit 10. Match IP address, prefix list, and it's called EIGRP. So that route map doesn't do anything, so I need to apply it to router OSPF1 and redistribute from EIGRP 100 subnets and use route map called EIGRP to OSPF. So now do show run section router OSPF. I apply that extra filtering mechanism, which looks like this: do show IP prefix list, which expects to find the exact match. That exact match doesn't exist because I don't have a prefix 30.33.00. So let's just see what is now being introduced into OSPF here. Let's repeat our commands, and there's nothing. There's just a default route introduced by router 1. That's it. We lost everything. So how do I match in that situation using prefix list on everything that is 30.33? And there's a different length of the subnet mask here. So there's two prefixes /24, two prefixes /28, one prefix /29, and two prefixes /30. So how do I do that? I need to change now my prefix list. So let's go back here. Let's take a look at this prefixes one more time. So I'm going to say no, this entry doesn't exist. It expects exact match. I will need to use an operator with that to match on all of these prefixes. So I'll say for now no, and what I'm going to say now, so match on the first, check the first 16 bits, they should be 30.33, that's fine, but now I need to use an operator. So if I do question mark, there are two operators I can use: greater or equal mask length, less or equal mask length. So if I want to use all of these 30.33, I would say less or equal 32. So because all these subnets are 24, 28, 29, 30. So check the first 16 bits, they should be 30.33, and check the network mask, it must be less or equal 32. So every mask that is, you know, for those two, those 2 bytes between pretty much 16 up to 32 in that context. If I hit enter, that route map still exists there. So by now I should be able to, let's just clear the terminal, do the same command, and voila, I have all these prefixes now, which are 30.33 with a network mask between 16, because that's 16 bits left, up to 32. Okay, cool. What if I want to do only 24? Maybe I want those 24. So I need to change the operator in my prefix list. So let's go back here, and I'm going to say no to that. By the way, I could use sequence 5 if there were more sequences, and only remove particular, but I have only one statement, so it doesn't make any difference at all. What if I want to do only 24? So I would need to use greater or equal 24, so that includes 24, but not more than 24. So I would have to add LE, less or equal, well, 24, and that matches only exactly 24. Let's just hit enter and see what happens. Let's go back to R3. Now let's clear the terminal. Actually, let's maybe see that in comparison. Now I'm getting only /24 prefixes. So only 24 prefixes are now introduced. What if I wanted to do 24 up to 29 but not 30. So all these, again, I would need to change the operator. So let's remove that for now and recreate. So greater or equal, that includes 24, less or equal, that 29, that will not encompass 30. If I do this, anything that is 30, that 33, with a network mask 24 bits up to 29 will be included. Let's go back here to R3 and try to do that again. And I have them all here, but 30. So what if I wanted to something between 29, 8 and 29? We already know how to do that. There's one more thing I want to point out. What if, let's say, there was a default route, and default route would need to be introduced into OSPF from EIGRP? How would we match on that one? Well, in that situation, let's say I'll create another one. I don't have it, but just as an argument, if I say 0, 0, 0, 0 and 0, that would be the exact match. So we're checking if the prefix is exactly all 0 with a mask all zeros, because we don't have operator. If we don't have operator, any of those two operators, GE or LE, that means that this is the exact match. So that would be a way of introducing only default route. If I add, however, LE32, that changes situation dramatically, because that means any prefix with any network mask. We don't check any bits, so we don't ignore what the bits are, because once we add the operator, this is no longer exact match. So any bits with any network mask, that will be anything. And that is how prefix lists operate. The next topic will be route maps, and after that I can start playing around with BGP protocol in this topology.